video, we want to find the interval of convergence of the sum from n equals 0 to infinity, -1 to the n times x plus 1 to the n over 2 to the n. For this, we're going to use a ratio test. So we're going to take the n plus first term and divide it by the nth term. So on the top here is the n plus first, divided by the nth term, and then take the absolute value. So -1 to the n plus 1 over -1 to the n is -1. X plus 1 to the n plus 1 over x plus 1 to the n is x plus 1. And the 2's are going to cancel, so we're just left with 2. And we want that to be less than 1 because the ratio test says that this converges. The negative will go away because we're looking at the absolute value. And then notice that x plus 1 over 2 do not depend on n. So the limit is just the absolute value of x plus 1 over 2. And so we want that to be less than 1. I can multiply both sides by 2 to get the absolute value of x plus 1 is less than 2, which means that x plus 1 has to be between -2 and 2. And we subtract 1 from both sides, we get -3 and 1. So now what's left to do is test the endpoints. So we need to see whether the sum converges at -3 or 1. So first we'll plug in x equals -3. So you have -1 to the n times -2 to the n over 2 to the n. And so this simplifies. You can factor out the exponent n and multiply the -1 and -2 to get 2. So this is 2 to the n over 2 to the n, which is 1. And so this one diverges because you're just adding 1 infinite number of times. Okay, next we have to plug in x equals 1. And so we have -1 to the n over, -1 to the n times 2 to the n over 2 to the n. The 2 to the n's will cancel. And now we have -1 to the n. So here we're basically adding, it's going to be it's going to be 1 minus 1 plus 1 minus 1, etc. So it's alternating between 1 and -1. And the thing is that this limit doesn't go to 0. So, because it alternates between 1 and -1. So by the test for divergence, we know that this diverges. So -3 and 1 diverge. So therefore the interval of convergence is between -3 and 1. And that is our final answer.